And I get minus 6.07. I'm not sure. I may have. I'll just check it again because I may have put something wrong.
So they wanted 4 sig fig, I believe.
994x. I typed something wrong. So I get minus 2.002.
For which one?
For
N?
N equals minus 2.2.
Oh, you'll have to remind me. How do I get this solver?
Oh, so you click option
Option, that's it.
and then calculate, and then it's solve N.
That's it.
Yeah.
Okay, what's next?
So you found N, so you just substitute an N for one of the equations, so the top one, maybe.
Okay.
So you can do 9.5750 plus 1.1793 times minus 2.002.
Okay.
And then find it for that. And I get 1358.4.
And sorry, K is what was I?
I got 1358.4.
8, and I'll leave it as 1358 4 sig fig.
Do you want to check? Because I think I may have done some copying errors.
How do I change this into a decimal?
You click SD. It's under log. Yeah.
So I get 6.073.
Yeah, it's because you didn't put N at the end of 1.5994. I made the mistake as well.
1 point. Yeah, so.
Yeah. And that would get minus 2.002. Yeah.
Okay. Any questions there? And does that match up with the mark scheme? Minus 1.999. See, yeah, I thought this might happen. So we're just slightly out, and the reason is because usually everything is to 3 sig fig.
Oh wait, hold on. We were finding N and K. And N and K. Oh wait, yeah. N and K are that.
Oh yeah,
yeah.
So,
no, yeah.
Yeah. N is that.
So N is minus 2.002 and K is 1358.
So they're saying that it should be minus 1.999.
Yeah.
The reason I think we're very slightly off is because usually you do everything to 3 sig fig, and so you correctly were doing 5 sig fig, 2 extra. In fact, this one wanted it to 4 sig fig, so we would have to do our working out to 6.
So they
Yeah, so instead of it, so like our 9.5750 would have to be like 9.5749 and then one other thing or whatever.
Right.
So our method is correct. I just I only noticed that too late, that it says unusually 4 sig fig, and so we should have done all these to 6 sig fig, and that's why we're slightly off.
So we should always do 2 extra significant figures.
Yeah, than the final thing.
Okay, I didn't know that.
Well, you did it. You were doing 5 sig fig.
I was doing that just because I usually go as big of a number as I can.
Okay.
So I think I'll just use the whole numbers next time.
Okay, and actually our A.
But K is far off.
Yes, did you solve for K or ln K?
I did ln K.
So like ln X or something?
Yeah.
So
I
they didn't want K, they wanted A, which is ln.
Yeah.
So do ln of 1358. What do you get?
I just changed the equation. I get 7.2. So I just removed the ln.
Oh, okay.
Do you want to do it as well?
I'll just
See.
ln 1 3.
Yeah,
So,
that's what I got.
I'll just try doing solver. So if we get ln K, so that's 9 point. In fact, I don't think it has to be solved. It can just be calculated. Plus 1.1793 times n, which we said was minus 2.002. Oh, so I'm still getting that like very close to 7.2. Let's take a look. A is that, but what is the reason? Oh, is there no working out or anything in this mark scheme?
Do they have their values of ln X and ln K?
Oh yeah, hang on. So how does that match up with our one? Minus 0.5. Your ln X is off.
Let me redo it.
All of your values are off.
I just multiply them by ln, right?
So you just put it in for a ln, is that what you mean?
So for the first one, I do ln 0.3075.
Yeah.
So 0.3075, and I get minus 1.1793
That's 9.3
still.
So this is part 3. Part 3 is ln X and ln Y.
I feel that earlier I may have got that though.
Radians or something?
I've never used radians, so I don't think so.
I don't understand this at all. So let me use my other calculator.
Okay.
So this one. So ln 14,400. That's that. So ln 1 like 14,400. 9457. Mercury.
Could we multiply their values by ln and see if that gets us something familiar?
Like ln of that answer?
Yeah. Nope.
No,
It doesn't get us.
Wouldn't make any sense. Am I missing something?
Maybe there was something in the question. Oh wait, above. Is that not the same thing? On the page above?
No, it just is. So log base. Oh wait, what? Scheme for candidates using log base 10? That's not right. Correct use of log instead of ln.
No,
and no
go up on the page above. Here. See?
Why are they doing that to me?
So
Silly,
that was
silly.
right.
Yeah, so we're correct. 7.218. Wow,
I
that's weird. Okay,
Well,
so this is down here is for students who made a mistake. They might get some marks if they did that.
okay. Oh, so
Okay.
they use log instead of learn. I see.
Yeah, they used log instead of lon, and so they just got like, well, you get 1 mark if you got all of them consistently.
Mm.
Okay, we were correct. Grant.
So 7.12, 7.218.
Yeah, and and the reason why our thing was slightly off, though, like minus 2.00 to 3 sig fig. So they would have allowed for it if you put down minus 2.00, because ours rounds to minus 2.0 to 3 sig fig.
So if I put minus 2.002, that wouldn't.
That is correct. Well, it gets the mark because it's accurate enough. Because
Okay.
that rounds to minus 2.00 to 3 sig
Yeah.
fig.
Okay.
Okay. Sorry about that. I was looking at the wrong bit in the mark scheme.
That's right.
Where was it?
So we were on.
So sketch a graph. I imagine that's easy for you.
Oh, I found mine. Okay. So for sketch graph found in part V. Oh, we need to rewrite the equation.
Yeah. So what is the
equation? So for use the values from part I to find A and B. Yeah, we got those. Just looking for a piece of paper I was using. That's odd. Okay. So find the. So what do they want again for question 5?
Draw the graph.
Draw the graph. So do I just put in my calculator?
Hold on, sorry. So part 5 was actually just formalize it first and then draw the graph.
So rewrite part I. What do we get for part I?
Part 1, ln y equals a plus b ln x. So that's just in terms of as y in terms of x. So what would it? So we have it as y equals c plus mx.
So y equals ln k plus n ln x. So for part I, we just did y equals x to the n. That's what we did, right?
So
y equals kx to the n.
Yeah.
Oh, so we do y equals 1358 x power of minus 2.002.
58 x to the power of, what was it?
Minus 2.002, because that's what we got for n.
Yeah, looks good. And then you would sketch that graph.
So I'd just I want to see what that looks like.
And their mark scheme says 1363 because our rounding thing is getting worse over time.
But they'd allow this answer.
Let's see. So yeah, follow through of their equation.
For my one, it says that there's a syntax error.
Y equals 1363x to the power of minus 2.
Minus 2. I'll just remove a few decimal points. Yeah, it still says syntax error.
No. So y equals 1363 x to the power of minus 2. I'll delete that one. And well, I don't see anything, but
Maybe it's because you're zoomed in too much. If you click zoom and auto, F2, then F5.
There you go.
So your one gets it, but my one does not.
Y equals 1363x to the minus 2. Are you using this
no.
x?
No, it's because there was one below that was a redundant equation.
Ah, okay.
Let me see. Okay, well, it says it's drawn something. Also, I found out that when I was doing sine and cos, I was zoomed too far in, so it wouldn't, or too far out, so it would make it odd. But yeah, so I get one that looks like a tower, or an asymptote on the y-axis.
Yep.
And on the left as well, in the negative zone, it's got the same thing.
Yep.
But I just need to do 0 to 360.
No. That's it. This is what the mark scheme looks like.
Oh, okay.
So just some kind of a curve where it's going like asymptote of x equals 0, y equals 0, and it's in this first quadrant.
Why does it have to be the first quadrant?
Like that is what the graph is.
For me, it goes in the negative part as well. If you click left on the calculator. For me, it goes negative.
On the left side or down?
On the left, so it goes negative x, but positive y.
I don't know why that is. And y equals 1363x to the minus 2.
63. I'll write it again to the minus 2. Zoom auto. Yeah, it goes on both sides.
Let me see this question. The intensity of the sun's radiation and the average distance. Distance is positive only.
Okay.
And so you only showed a positive one.
Okay. I'm just wondering why yours shows the negative as well, but I guess
I think there's probably a parameter in my settings that says just from 0 to something.
Yeah. Also, my one has just lost the ability to show numbers sometimes. Yeah.
On the graph, is it?
Yeah, on the graph. It doesn't matter though, because I can work stuff out nonetheless.
Okay, you can, I think, yeah, play with it.
Yeah.
Ouch. And, okay. And then, so you sketch that graph. And then, last one.
Last one. Earth is one astronomical unit from the sun. Find the intensity of the sun's radiation. Are the values above astronomical units as well?
I say the intensity of the sun's radiation.
Y is, astronomical.
So X is astronomical units.
Yep. So they say that Earth is 1, so X is 1. They want us to find Y.
Yeah.
So I use the equation that we have, which is Y equals 1363 X to the minus 2. And then I just put it in there.
Yeah.
So from the graph, how could I do that? Oh, I can find X from the graph straight away. If I do that and trace, and then, what was it, 1?
Yeah.
What was it? Trace 1. They say that the Y is 1363 as well.
Yeah.
I don't know if that's right.
Yeah, I have 1363 as well.
So it stays the same.
And they have 1363. Yeah, rounded is 1360. It's because 1 to the power of anything is still 1.
Yeah. Oh, so it would be times 1. Yeah.
1 to the 2, 1 to the minus 2. Yeah.
Okay. I think it was just good practice to use the trace function.
Yeah.
Because it finds the X point, in particular X point. Okay.
Any questions there?
Nope, I got through that one. It's just, it confused me a little bit.
And did you mention question 10?
Question 10, it was just that when I got to part 3, I didn't realise that I had to integrate v displacement. So maybe if we went through it fairly quickly. I got most of it, but there were some parts where I got a bit stuck.
Basically, you know how GCSE you had a speed time graph or something,
Yeah.
and if you find the area under the graph on a speed time graph, that gives you the distance.
Yeah, what I did at first, which took a lot of time, was I thought they gave us an acceleration, but they didn't. So my Suvat equations were giving me wrong values. Yeah, I realized that I had to do 4 times 12.5, which gave an imaginary total, and then just found the little triangle in the corner, because that would be the difference.
Okay, and so for a velocity time graph, velocity is like speed, and so it gives you displacement.
So 4 times 1.5 was 50, and the displacement that he got was 45. So the area of that little triangle was 5 meters, and then I could just do half times 4 times x equals 5, and that would give me the time, which ended up being 2.5 seconds.
And you don't necessarily need to integrate to find the area.
Oh no! That it was for a later part of the question.
Okay.
So yeah, I calculated t, and then find an expression for Rory's displacement at time t seconds for 0 t, and that I just got stuck on. For part 3.
Seconds. So you would just do it in terms of t. So you had the graph. Is that right?
Yep. You had the graph and you had the value of t.
And so you just find the area of the graph in terms of t. So just find the area of the graph.
So it's 45 because it gives it to you in the question.
So it should be t should be in your answer. So like literally just find the area under the graph.
Yeah. So the area under the graph is 50.
In terms of t.
Oh. It would be half times 4 times 12.5 plus 12.5 minus t.
Yeah.
Because that's the area of a trapezium?
Yeah.
Yeah, okay.
12.5 plus 12.5 minus t times 4. And that's it. They didn't say simplify it. That's it.
So then the next part is they want us to find t, right?
And did they tell us what the area is? 50, did you say?
I calculated 4 times 12.5 is 50.
Okay.
And they give us 45 as the actual one. No, it's 45, not 50.
Okay. Okay. Yep. And then you just solve t for that. You can use your calculator for that.
Yeah, as it was 2.5.
Okay. Was there any other part of that question you were stuck on, or you're okay with it?
It was from 3 onwards.
So you just did t? You just did part 3?
I did part 2.
Calculate t. Find the expression for Rory's displacement at time t seconds. 0 tt. So that's the thing. He proposes a model in which the acceleration is constant till time t seconds. Sketch the LC time graph.
So yeah, with this one, I looked at the
his displacement
answers.
is just the area. Oh, at time t. Do you have to make a whole equation? Oh, sorry, it's a suvat.
Is it?
Looks like it's suvat. Yeah. So an expression for his displacement at time t. So t equals t. An equation for his displacement. So that means s also equals s. And is there anything else we know?
We know that at time 0, u is 0.
So u equals 0.
And acceleration is 4. So a equals 4.
This can't be done using some, because he has two different accelerations. Maybe they didn't use. So the acceleration is that for part 3. And 6. How did they get acceleration? Is hang on, oh, between 0 and t. Yeah. And so from 0 to t, so it's just one acceleration there.
So
a equals
so
4.
they ask for the displacement, right?
Yeah.
So I have to integrate the acceleration equation.
No. Like, what is a suvat equation that involves t, s, u, and a?
S equals ut plus half at squared.
That's it.
So S equals 0 plus half times 4 times t squared.
T squared. And so S is 2t squared. I think that's it. I'll take a look. But yeah, so because it's one acceleration, so I thought that they were talking about the whole just in general. But so that's why they limited it. Like, it's somewhere between 0 and t, capital
Yeah.
T. So they said that it is a half times 1.6. His acceleration is 4 over 2.5. Is his acceleration... Oh no, his acceleration isn't 4, or is it? Let me read the question.
Oh no, the acceleration isn't 4.
No.
He accelerates to a speed of 4.
Yes. So we have to calculate acceleration.
So acceleration is unknown.
And so how do you get acceleration from a velocity time graph?
You find the gradient.
Yep.
So it's 4 over 2.5.
Yep.
So a equals 4 over 2.5. Which is 1.6.
Yeah. And so it's a half times 1.6 times t squared.
So yeah, that's equals 0. Okay.
And did you get the rest of them, or was just...
No, I didn't, because I got stuck at 3.
Okay. And then how about part 4 then?
Uses model to find the time taken to run the first 4 meters, and our equation was so we can plug in 4 for S.
Yeah.
So, and then I can use the solver. So 4 equals 0.8 x squared, and I get minus root 5 and root 5, so it has to be root 5 because time is positive. I can't go backwards.
So time is root 5. And what is that roughly?
And that is 2.236.
2.24 seconds.
Mm-hmm.
Okay. Next one.
What? It's a quadratic equation. 0, 0, and its maximum point of S4. So phase last time S seconds. So this one would be velocity time, but with a curved beginning because it's quadratic.
Yeah.
So start at 0, 0 and just curve. Oh wait, diablo.
Like that.
Yeah, because its maximum is at 4, which is the maximum velocity.
Okay. And I would show S on the x-axis.
Yeah.
Okay. And then this one.
Say we're reason whether S greater than T or less than T. But since the area has to stay constant, then S is greater, I think.
Then S would have to be okay, because what? Because it's curving downwards.
Because if you draw a straight line and then flat, there'll be like the curve will go above it and then below it. So it will have to be greater.
Yeah, so that's what they accept that. So S is greater than T, equal area. Okay. And 6. No, that was it.
Ah, okay.
Yeah. So was there anything else?
There was one thing.
Yeah.
We were doing a little bit of projectile motion in class.
Okay.
I can tell you exactly what the question was.
Yeah.
So say that you're at the top of let's see, you're 10 meters up.
Mm-hmm.
So you could say you're on top of a 10-meter cliff or whatever. And then you accelerate or you kick a ball so that it's going 10.09 meters per second at a 30 degrees angle from the ground, which is 10 meters up.
Okay.
And then there's a wall which is 20 meters away. And will the ball fall short or touch the ball?
That's 10. This is...
Oh, and it's kicked from the top for 10 meters.
And so this makes a 30-degree angle?
No. Yeah, and it follows the straight line that you've drawn.
Okay.
You could just draw it from the top of the line that you've labelled 10.
So usually I think it's something like that.
Yeah.
And so there's like... Okay, so there's a wall or something.
At 20 meters. Which is on the ground. Which is 10 meters below where you kicked the ball.
Yeah. Okay, so if you resolve different ways...
So what I was doing was I was resolving the vertical and horizontal, and then I looked at the time it took to go up, stop, and then fall down again. But that was wrong.
So going up, A is minus 9.8. Did you get a starting velocity or something for the ball?
Yeah, 10.09 meters per second.
10.09. So that might be, is that 10.09 cos 30 or something?
Yeah, sine 30,
Sine
if it's
30?
going upward. Yeah, it was following the hypotenuse that you drew.
So that's u.
That's for the vertical.
Let's see, u, a, so v we don't know, t we don't know, and s
is minus 10. Because it falls minus 10 meters.
Yeah. And so what did you want for that time?
Wait, why could it not be 10 by itself? And why is it minus 10?
So, well, we're trying to find the time that it crosses here.
Yeah.
And so that, at that point, the displacement would be minus 10. No, that would be if it goes down, isn't it?
Yeah, because what they said is the wall is on the floor. So it's where the little line where you drew 20 is, and it's not infinitely tall.
So if we're trying to resolve vertically, so you could just find its maximum, and you could say at its maximum v is 0.
Yeah, that's what I was thinking. But he got a time of 2.5 in the air.
So what would be s?
We could use A, U, and V. So S U squared plus V squared equals 2AS?
Yeah.
Yeah. So V squared equals U squared, V squared minus U squared over 2A equals S.
Okay. Yep. Put in the solver.
So I get 1.29.
And how high was the wall?
So 1.299 meters.
And
so then you add it together, so it's 11.299.
okay.
So that's it at its maximum.
Yeah. Oh, but we don't know. Ah, yeah. What height is the wall?
Which will
Wasn't there a wall or something like?
the 21.
Yeah.
It's 20 meters away from where it starts. So presumably it's on the floor, they said.
Like
So I think
was the
we could
question not does
imagine
it go over the wall or something?
it would be, does it come into contact with the wall?
Ah, okay. Yeah, yeah. So you just find time. For the wall, when you're doing it this way, you would use S equals VT. Or S equals UT, same thing. So S is 20. U is 10 cos 30. Well, we don't need even the 20. You can just call it. No, will it follow? Yeah, so what was the time for the top one?
We didn't calculate it.
Oh, okay. I thought you got that in your own one. Okay, so this one up here. We want the time when. So what? Does it reach the wall or something before falling down?
No, I don't think so. No.
So we would use s equals -10 for this one up here.
Mhm.
Because that's when it hits the ground.
Yeah.
And we would try to get t.
Mhm.
And did you say you got that t?
No, I didn't. I got the S.
Okay. So what would be this?
So we want T from A, U, S, and T. S equals U, T plus half A, T squared.
Okay.
So when we solve that, -10. Oops. U10, got it, 9. X times -9.8 times X squared. And I get two answers, but one of them is negative, so I get 2.791. So
Sorry,
T.
2.791, and so
Mhm.
that's your t down here.
Okay.
Because if you resolve vertically, you can just use s equals ut or s equals vt, because u and t are the same. Because there's no negative acceleration due to gravity.
Oh, I didn't put sine 30 by accident. And it's a syntax error. Hold on. I'm getting a syntax error. Oh wait, no, it says 2.03 now.
The whole thing?
I did -10 equals 10.9 sine 30 times.
Oh, so sorry, what was your solution for the time up above?
Wait, I'm just redoing it because I got it wrong.
Okay.
So
So the time I get is 0.74379.
I still get 2.033.
So did you put it into your quadratic solver?
No, I just put in the solve and did -10 equals 10.09 sine 30 times x plus half 9 minus 9.8 times
Oh,
t
sorry,
squared.
I used the wrong. So that should be 10.09 sine 30. So a half times that. So are you doing minus 10 equals 10.09 sine 30
times x.
yeah,
Yeah.
plus a half times minus 9.8 x squared?
Plus 0.5 times minus 9.8 times x squared, yeah.
So because it's a quadratic, you might need to use the quadratic solver.
Okay. Equation polynomial to which one is a?
So
So
a
half.
is the t squared one.
Half times minus 9.8 times x squared. And b is, which one is b?
In front of the
Minus,
the u.
so 10.09 sine 30 times t, and then the c is plus 10.
Yeah.
So I get 2.033 and minus 1.0.
I don't know. So, well, a half times minus 9.8 is minus 4.9.
If it were to drop 10 meters, would it be closer to dropping at 0.7 seconds or 2 seconds? And if it were kicked upwards, 10 meters.
Oh, I don't know. So I'd have to see the question. I don't really.
Yeah.
But so if you're
okay, we'll use your one.
You just sub that in then.
So we sub that in for 10.09 cos 30.
Yeah.
Okay, so let's see what that gets us. 10.09 sine 30 times. So yeah, with my value I get 10.25 meters. So I reckon that for your one you'd get less distance.
Yeah, and so it doesn't touch the wall.
No.
Yeah, doesn't reach the wall.
Okay.
I don't know why we're getting two different things for the quadratic thing. It's kind of just messy.
Yeah.
Yeah. So these ones you tend to resolve vertically first because you always have acceleration due to gravity. You can use that to get whatever you need to, and so here s vertically will be minus 10, and this is the point that we're kind of referring to. The initial is that s is minus 10, yeah, and then once you have your time, you just sub it into the horizontal one, which is s equals ut.
Yeah, because it's what's the original equation?
Ut plus a half at squared, but there is no a. There is no air resistance.
Okay, got it.
Yeah, how was that for you, Gregoire?
It was good. Thank you very much.
All right. When is our next lesson?
I think we said that